Okay, so we just finished talking all about chemical and physical properties and chemical and physical changes, states of matter, and now we're going to be talking about solutions and mixtures today. What's the difference between the two? What are the different types of the two? So, first we have heterogeneous mixtures. This is a mixture that doesn't have a uniform composition. And what that means is it kind of just doesn't look like one, right? So you can kind of see the individual substances that are in it. So, like Chex Mix is a heterogeneous mixture. It's a mixture, it's one thing. We call it Chex Mix, right? But you can obviously tell what each individual part is. So, that's a heterogeneous mixture. Suspensions are a type where it kind of looks like it's uniform at some state, but if you were to allow it to sit there and settle out without touching it, you'll start to see those particles separate, right? So think like salad dressing, think like muddy water. If I were to shake it up, right, it all of a sudden looks uniform. It looks like one even thing, but you leave it on the counter to sit out just for a couple minutes, you'll start to see that, oh, this is actually heterogeneous. I can see the different types of substances in it. Another type is a colloid. So, colloids are a type of heterogeneous mixture that has to do with the sizes. It's kind of in between like a solid heterogeneous mixture, but also not quite a solution. So it's kind of somewhere between like it looks uniform, but the particles are actually really different sizes. So we have this kind of intermediate state we call a colloid. A common example of this would be milk. These are also a bunch of types of colloids. This table, you have this in your book, so you don't need to write it down. I just put it here to bring attention to it that you have it. But main idea is colloids are categorized based on the different particle sizes in their different phases. They're kind of like a hybrid solution heterogeneous mixture. So then homogeneous mixtures, depending on what part of the world you're from, they might also call it homogeneous. I say homogeneous. So these have a uniform distribution. So think like salt water, right? You stir a tablespoon of salt into a cup of water, it can kind of dissolve. And unless you put a whole lot of salt, you can't really tell that there was salt in it. Um, so solutions contain two or more substances called a solute and a solvent. A solute is the thing being dissolved, so our salt. A solvent is whatever is causing it to be dissolved. What is it being dissolved in? So, like the water for this example, right? So, we typically think of solutions as liquids, but they can also be gaseous or solids. If it's a uniform composition and something essentially is dissolved in another one, it's a solution. So, when talking about homogeneous mixtures, if a substance dissolves in a solvent, right, so like our salt, we would call it soluble. When two liquids are soluble in each other, right, meaning that the particles of one liquid can completely saturate the particles of another one, and vice versa, we call that miscible. When a substance cannot dissolve in a solvent, we call it insoluble. And when the same thing happens with two liquids, like you can separate them, and we call that immiscible. So now a little bit more about solubility. So remember that solute is a thing dissolved in the solvent. So an unsaturated solution is when I have less of that solute dissolved um, than what is required in a saturated solution. And what that means is, let's say we're going to go back to that salt water, right? There's a point when I can't dissolve any more salts. If I'm underneath that point, it's an unsaturated solution. A saturated solution is when I have a maximum amount that can be dissolved. So right when I hit that point, that is a saturated solution. If I go over that, that is a supersaturated solution. And how we typically get supersaturated solutions is that we heat them up, because if you heat up a solution, you can dissolve more in it. But typically, when you lower that temperature again, it's going to start to settle out. That's how we make rock candy. So the solvation process, basically the process of how do we dissolve things? So basically, the solute particles are surrounded with the solvent particles, right? Um, and by doing that, they're breaking apart the actual bonds. You'll learn more about that in chemistry, but basically, solvent is surrounding the solute. That's the process. And lastly, some factors that can affect solvation, right? So, what determines if something is soluble in another substance? So, one is shaking it or stirring it. And you may have come across that several times. You want something to dissolve quickly, you start shaking it. Because the way that it's dissolving is by creating collisions. You create those collisions between the solvent and the solute, you allow them to interact more, increasing the rate at which they can actually be saturated with that solvent, breaking apart the solute, right? So if I had a sugar cube versus like granulated sugar, that granulated sugar is going to dissolve a lot more. That is because there is a greater surface area, which just means there's more access to the different particles. If I had a sugar cube, um, that water would have to break down the outside of the sugar cube and keep breaking it down in layers as opposed to having access to all these little particles at one time. And then, like I said, increasing the temperature because that increases the energy so more collisions can occur. So, yeah, that is lesson 11.2 solutions and mixtures.